Hey guys, can you hear us?
Yeah, I can hear you.
Yes.
Awesome. Okay. Hey Kenny, what's up? Okay, so we've got some new members today. I hate admins. Luke, what's up, guys?
Yeah, hi.
Not
Hey.
much.
Good to meet you both. So why don't we just take like a couple minutes and Kenny says hi. What's up, man? We can just hang out for a bit, wait until everyone sort of hops in. Then we'll do kind of like a recap of everything from the previous call and then jump into GVM. Just going to double check everything is recording correctly. Hey, Grant. Okay. So what do you say? I mean, should we just like jump straight in?
Yeah, why not?
Okay. All right. So on our previous call, I think, what was it that we did last time? I think we probably went over
MDev GPU and the basis of the Haskell side of this. As many of you know, the compilation process for the Haskell code has been exceeding 500 gigabytes in RAM. So part of the way we're trying to reach out to the community is to make it a little bit easier for us to make it a little bit easier for contributors to add to our project. So we've changed it to C/C++, and we will be releasing it on the GitHub after this call is finished.
Yeah. So from Rust to Haskell, back to C.
Yeah.
So yeah, we're doing the big round trip.
Equine.
Yeah. So the only other thing about this particular release is I think it brings us much closer to sort of independence from binary blobs. So we're getting near the point, I think, now where we're running everything as open source. What was this question? C++. So did you want to go over the parts that are in C++?
There are a few times that C++ is faster than C. From heuristical knowledge on my end, at least, I have noticed that once you use C++ linkers, the optimization of C++ linkers are a little bit faster than C linkers in terms of runtime speed.
Yeah.
There's also a few other optimizations. So what ends up happening is we use C++ mostly for the end product. So the executables as well as unit tests, those are done in C++. Virtually everything else is done in C. There's also the capability for the Brave, so to speak, to add in assembly.
Inline assembly.
No, we actually support follow-on assembly.
Oh, amazing.
Source files, but we encourage you not to add those in.
Yeah. Okay, so a couple of logistical things that we've settled on. We're using Doxygen for all of the documentation. We have documentation standards. There are some expectations on anything that's added in. So I think we have import graphs. I think we have failures. I think we have restrictions listed, side effects listed. Do we have anything else for Doxygen?
I think that, to-dos.
Yeah.
Because there are certain code segments that are not at the level that we want them to be. So we have it in the to-do list. We have also a ticketing system.
Yeah, this was a request from someone in our previous sort of discussion. I think it was on the Discord regarding how can we actually, write out a list of the things that we should be doing. Whether or not it's just us coming up with that list or it's actively other folks helping us come up with that list, I think it'd probably be better that we kind of have something set up so that maybe during these calls, maybe during discussions in the Discord, people can make suggestions. What could we put into the actual ticket system, things that ought to be added in, that kind of thing. So there is a link to that, I think, on the docs.gvm or linuxgvm.org. Yeah, so the other thing is we do need at some point something to help us more sort of formally steer like a roadmap. So what we were thinking for that is rather than having something where we kind of just like arbitrarily come up with like high level goals as opposed to individual kind of tickets, maybe we could go to something that is like a kind of request for comment type of system. So if we have any kind of interface that we want to make changes to, so for instance, something that we were thinking of was in-place spot generation or a type generation. So like an application could actually make a request into GVM for a specific mediated type rather than generating them ahead of time. That we, before we would ever build anything like that, we would want to have like a proposal, like here is an actual design for how that would work, and then do a request for comment so folks can give their input on how other ecosystems can connect into that. And it's not just something that we've created to try to like extend libvfio or one of our management systems to connect in.
Yes, we also encourage the community to make requests for comments on themselves. We will take them all into account.
Yep. Okay. The coding standards. Another thing we're thinking of here is we want the coding standards to be in line with those that are in the Linux kernel. So at some point, if we try to upstream anything that we're building here, that all of the structure of the code base is already ready for that, and we don't have to go back and refactor things in a significant way.
It also helps prepares developers for the kernel module section of the GVM.
Yeah. So actually, I think probably right now, now that we're talking about that, Grand, I know at one point you were working on a package, and we've basically done nothing with packaging.
Our packaging is supreme.
Yeah, it's amazing because it doesn't exist.
Compile on your own machine.
You
need over 500 gigabytes of RAM.
Well, hopefully not anymore. Grant, did you have any suggestions on how we might actually go about making packages better? I know somebody was suggesting something with like an R package. Is your mic working, man? I think he unmuted, but I can't hear him. Very quiet. I think he's trying to make his mic work right now.
You're muted, actually.
I'll just give him a second. I can't think of anything for packaging. Okay. Yeah, I mean, it kind of depends on which driver backend we're dealing with. So we've had some thoughts on dealing with other driver backends. That's another thing we could probably discuss. So we do have like an onboarding process for other driver backends. So one of the things that I think would make a lot of sense. Hey, Snowman. What's up, man?
He's listening on.
Yeah, fair enough. I just see that.
Also, before I forget, because I noticed that Felix is in here, I'm happy to announce that we officially support TOML, as you have been requesting it from us.
Yeah. So I think it's the only document format at the moment. So no YAML, no JSON, so just TOML. What did Ben say? Packaging. Might be an idea to split the backend. Hold on, I have to let me just double check what he said.
I'm gonna move a little bit closer.
Packaging might be an idea to split the backends into separate packages with requirement on the base package, perhaps. So ideally Intel and AMD separate. Yeah, so that makes sense. So that was something that we were thinking over, Because we have an onboarding process now for different drivers. So obviously we started with documenting the relevant functions for driver IO mediation. So internal resource management, how it interfaces with mediated core, all the functions we would need to call externally from GVM to set up the internal driver IO resources in order to do mediation. So we went obviously ourselves and documented that. And in the context of other driver backends like AMD GPU, I think we could probably do it ourselves, but it might make sense to have other people and like, Tens Torrent, those guys actually do some of that work themselves.
Yeah. So in the onboarding process, there's two major components and a third more closer to the GVM user suite component. The GVM project is split up into two major sections, the user space components and the kernel space components. Unfortunately, at this moment, the kernel space is not anywhere close to being able to run in an efficient manner that you guys will be able to even start testing with just yet. The user space component has several layers to it. We have kind of like a presenter plugin system, which can be developed by vendors or by any individual. This is a mechanism by which we allow for NVIDIA to maintain grid and to actually allow grid to be more or less hidden from the public view. These plugins can be a proprietary or open source. We encourage at least one open source plugin from each vendor. The closed source plugins will also have to be compatible. So an individual who does decide to buy grid using GVM is able to actually just simply switch one line of code and instead use proprietary plugins. This allows us to actually penetrate into more open source communities, such as the Cubes project, as well as more high assurance capabilities, which is one of the things that we are deeply interested in accomplishing.
Yeah, I think we can get into that maybe in a couple minutes. But you've touched on a number of things that we probably ought to elaborate on further. So the open sources, I think the way we're thinking about it, is somebody asking a question? Don't hear anything. Is it just, who was it that was saying sound doesn't work? Just him? Okay. Everybody else can hear? Okay, good. Yeah, so the way we're thinking about the open source is we are thinking about it in terms of common APIs between the different vendors. So for example, in the context of non-paravirtual guests, so guests that are running normal GPU drivers, not paravirtualized ones, and it's running, let's say, on an NVIDIA device, it's running on an AMD device, it's running on an Intel device. We're thinking about that in the context of OpenGL, DirectX, and Vulkan, because those are APIs that are in common between all of the different vendors. In terms of specialized APIs, so compute APIs like CUDA, I think with GVM, we actually have the ability to have somebody load the grid guest driver and install a NVIDIA CUDA license that they've purchased from NVIDIA, and they can gain all of the additional functionality around CUDA, but not by default. So if they're running a guest driver, a non-paravirtual guest driver, that functionality won't work. So I think that makes kind of a lot of sense because it kind of evens the playing field, at least in the context of people who are doing open source. But it also gives the vendor the ability to continue to monetize that API, which is presumably where the majority of that monetization is coming from.
Yes, there's so going down a bit further. And
should we just cut the recording now and start jumping into the unrecorded?
Well, this part here is more so about the structure. Yeah, okay. This one's not. Okay, so in the GVM user suite, you'll also notice that we have a GPU component and a GVM component. Each vendor, we need to develop both a GPU and a GVM component for those vendors. This allows us to actually, the GPU component allows us to connect directly to the driver, or in the future, a GVM stub for that particular vendor, and develop the components we need there. This stub and this management interface for this driver gets sent into the GVM component. The GVM component is how we actually handle the spawning up of the VMs, as well as connecting to the correct driver and setting up the correct interface in the correct manner. This is another section that is vendor-specific code in the GVM user suite. And then finally, there's the kernel modules, which we can get into, but I think it's better if we wait until those are more refined before we get into those ones.
So the other thing we were thinking of with the presenters was a method by which we could do direct memory introspection into the guest. So with the presenter plugins, this would probably involve something with Looking Glass, where rather than having the inter-VM shared memory device as a separate driver that we have to pass in, GVM would have a presenter plugin where we're grabbing the guest frame buffer memory directly and presenting it right into Looking Glass client. So then in that context, it wouldn't be something where we have all this extra kind of like nonsense of going into the guest and installing additional drivers and making sure that the inter-VM shared memory device is recognized by the Looking Glass host process. And then there is a Looking Glass host process. And then we have to do some nonsense with like, the NB or NV frame buffer stuff, or whatever the other capture APIs happen to be. Rather, it would just be grabbing it from the host and showing it directly. So we would have to have then probably a fork of Looking Glass, and we would do a pull request back to him.
So what I think we could do is we could switch, so we can do this kind of like that, but we can make it more like Axel library. This will allow for vendors like Intel, NVIDIA, AMD, Tenstor, and to actually connect to that library when building the plugin system, so that we could actually allow for more vendors to have the capability of Looking Glass without having to necessarily open source certain proprietary bits.
Right. Well, we know that in the context of Intel, they're doing their, what is that? They have their
mediated
indirect stuff, indirect display driver for the guest.
Of course.
And then it's presented straight into the host. So ideally, it would be good if we could build something like that where maybe it was something in GVM where it is like a presenter plugin that, maybe it is a virtual display that goes into AMD. Maybe it's one that goes into
I think so.
Yeah. Okay. So just like if you obviously there's a couple people here that haven't been in the call before. Kind of the way that we do the structure of the call is we do a recorded section. On our less good calls, we tend to not get audience interaction going. So this is probably going to be one of those. And on the better ones, we do have audience interaction. But at some point, we do this Chatham House rules thing where we effectively cut the recorded section and then jump into the unrecorded section. And then we can have sort of more conversations about the roadmap, what it is that we should change, do better, that kind of thing. But just before we jump into that, I think maybe we should briefly touch on the Cubes use case. So right after this, we're going to Cubes OS Summit and spending a bit of time with them, particularly dealing with how we can do GPU mediation in that context. Now, there's a couple things with them where it's going to be a little bit difficult. The first thing is we have to get the Looking Glass memory protocol ported from the inter-VM shared memory device protocol, so the IVSH mem, to Grant tables, which is their memory sharing primitive, which is different from KVM. That's the Zen memory sharing primitive. And then the other thing that we have to do is they have this kind of ass backwards method of
IOMMU.
Not just that, but it's like all the memory is on the host. And well, it does it's the identity map of the memory into the guest. It's not actually properly like IOMMU group separated. So we're going to somehow have to deal with that. But the way we'll get into that is more about like use cases around folks that want to have applications basically separated in like a high assurance context. So like you could imagine something where maybe it's somebody using like a CAD program or something, and that CAD program has a bunch of sensitive data in it, and then they want that effectively like walled off from, let's say, the email program that has like PDFs in it, that kind of thing. So ideally you do that with virtualization, but with cubes so far, the GPU has been a trouble spot because it's not really been possible to virtualize most like laptop GPUs, for example, which is realistically where cubes is actually running. Was this what was this question here?
This is Felix mentioning that it's cool, but because
That's because the host application actually feeds back the positional information of the mouse and cursor updates and so on as well. It's not just the frame buffer. So there still will need to be an application running in the guest. It's not extremely critical of latency. You could probably get away with the socket transport there instead of shared memory.
Yep.
But you'd need to do some testing to figure that out first.
Okay, that makes sense.
We'll figure out a way, but good input here.
Yeah. Okay. The only other thing that I was thinking was in the context of Cubes OS, have you looked at grant tables as a memory sharing primitive over IVSHMEM?
I haven't had the time to look at cubes, let alone any of how it works at the moment.
Yeah, fair enough. Okay. So that's interesting, because the other thing that, I mean, just like without even thinking about the grant tables thing or Zen in general, it probably would, as like a longer term architecture, make a lot of sense to do something around like a plugin for different vert drivers. So something where rather than having to input the IVSHMEM, having like a library that then can go into a hypervisor where then whatever the underlying like GPU driver is, that we could get the memory out without having to necessarily have like the IVSHMEM. So
yeah,
we'll probably
that would be ideal.
Yeah, we'll probably at some point do like a fork and then probably try to merge back into master.
Yeah.
So, you know,
Yeah.
we'll have like a pull request with like 10,000 editions at some point, probably.
Yeah. No, I'd be happy to lend a hand to that. The only thing that you need to make sure of is that we retain compatibility with the existing, obviously, method of capture. So there'd need to be some kind of a agnostic layer. Or an interposer, I guess, between the current system and what you're building now, as well as our own. So we don't break compatibility, because there's a lot of people that won't have Intel hardware to do this on.
Yeah, or for example, the GVM running on NVIDIA. Yeah, and presumably there's going to be people that still want discrete pass-through and they don't want to run the hypervisor. So that makes a lot of sense. Okay, so what were we on the schedule? The only other thing that we did touch on, maybe I could get your feedback on this, was the idea of having, so with GVM, it's obviously like we're generating our own vGPU types and not like just having a hard-coded thing where we then set it on boot. One of the things though that people have mentioned is that when they want to regenerate the types, if they've been set on boot, they basically have to reboot at that point. So we're kind of in like a bad situation where we have to somehow unload all the context in the existing system and then like basically reload it via a restart. So it might be better eventually to have something like an in-place type generation, so we can like somehow send a bit of data about what exactly the vGPU type is, like the amount of memory, like the vert display properties, the bar length, that kind of thing, and have it just generated in place. But we don't want to get into a situation where we're like, hey, look, we've built this API that we only libvfio uses, and like 99% of people who use libvirt are like out of luck. So we were thinking about trying to do some sort of like request for comment thing, but mostly people do that in email. And I don't think anybody in our community uses email. So how would you suggest we do that?
Unfortunately, I would have to say email.
There's also a way to do it using GitHub issues. That's a way that Nimling does it, actually.
Yeah, that's great. But if you want to get the libvirt people involved, as well as QEMU, because I'm sure they'll be obviously jumping in on this too if they want to integrate, you're going to have to resort to their mailing list. It's about the only way I know of to contact or communicate with them.
Yeah. So wait until we have it's like, hey guys, we're shutting down the Discord. We're all on email now.
We'll have the email server have a bot that mirrors a mailing list to the GitHub, and the GitHub does a mailing list.
We'll have like emails mirrored in the Discord. That'll be amazing. Okay, that makes sense. So I think with all of that stuff out of the way, why don't we cut the recorded section. Then GNF, if you don't know, we do like a recorded section, unrecorded section, do like Chatham House rules so we can discuss everything without really attribution to any person.
Yeah.
So I'll just go tell our recording guy to cut it. Give me a second.